Not laugh. SimPEG Meeting, Halloween. Oh, I'm excited.
Boss, what do we do?
That's scary. Yeah, so a couple things I was hoping to go over. I mean, maybe we can chat a little bit about Exploration 17.
Yeah, I think that'd be fun.
And then the other big thing, which I think is awesome, is that we created a pull request for the VRM. So I think this is a great chance for us to figure out some things on like how do we bring in a new contribution that is fairly substantial, and how do we work on like, together sort of getting that into the SimPEG framework and really like making it feel like SimPEG, because the structure, naming conventions, all that sort of stuff matters. And so how do we go about doing that in a way that is positive, not a pain in the neck for people, but also like maintainable long-term. So,
yeah, and it'll be good to hear Devin, like, what was his experience and what did he like or what he doesn't like.
Yeah, and this will be ongoing. And you're like free to chime in and say, hey, you guys, you're driving me crazy.
Come on.
You structure, too much structure.
Yeah.
It wasn't too bad.
Okay.
Oh, that sounds better.
At the end of the day, I found a way to make it work that wasn't me fudging stuff so that it would work.
Okay.
But I did find that the base level of things, like, well, I can talk about it on the board. I can just start and so I do the Exploration 17.
So let's maybe do Exploration 17 first. Does that work for you guys?
Yeah. I wasn't there, so.
You were there.
Well, yeah. Not at the expo itself, I guess.
Okay, so Exploration 17, it's an interesting conference because they do it every 10 years. And it was very much exceptionally mining focused, very applied. So most of the talks sort of started like with a bit of a retrospective on what things have happened in the last 10 years. And then most of them included some sort of like forward-looking statements on what they think is most important. The things that like stood out to me, where I think actually we can make a big difference with SimPEG, is the integration of geology with geophysics and bringing in a priori information, bringing in knowledge of where interfaces are, what the physical properties should be like, and what the geologic setting should be. I think that's something we've tried hard to at least create space for. Maybe we don't have all the utilities and all of that yet, but I think that that's going to be a really exciting space that I think we've done a lot of groundwork for.
To have the framework able to customize their own. That's what we were talking about yesterday, right?
Yeah.
Right. Like it's going to be a need of like specific. We need that tool to be able to do this, and I want to spend 5 years making it plug and play.
Yeah.
That's right.
And one of the things that came up, I had a really good chat with Nick Williams, and actually this even came up in the disc with Rob Hurst, was that what really stands out in a lot of ways to people is the ability to view currents with SimPEG. And like I found that sort of interesting. So you can actually pull that out of SimPEG, in theory, but we sort of built it in naturally that like, you should just be able to grab that and look at it. And people are very, very impressed by that because it is such a powerful survey design tool. Like you set up your electrodes, am I lighting up the thing that I care about? Yes or no? So people are pretty stoked about that. And then we had a really good chat with Glenn, who's with DAS, and this is they're really interested in potentially using SimPEG for inverting some of their DC data. So that's why I put out that call yesterday for just some more DC examples, just to show that like, hey, it's on our radar. We can actually invert 3D DC. And one of the things that I found really cool about that conversation is that he totally understood the open source mentality of things, in the sense of like, we've done some work, but he's not expecting that like it's a production code yet.
Off the shelf.
Yeah, and he also realizes that if that's what they want out of this, they'll also have to throw developer time at it, and that's something that they're potentially going to do. So it could be a really cool case for figuring out how to make that sort of partnership work.
I guess. Do you think, let's say a company like them, they put a full-time programmer,
Yeah.
right? Like downlink, would they send back, like comments like, oh, you guys should change this on the base framework or something, Could it be part of some sort of agreement or?
Yeah, and I mean, I think that would be something that like would evolve and we're figured out as we go. Like the way that I would see that sort of happening first, is like we would need to get them to some of the SimPEG meetings, sit down and chat, and just sort of like see how
they were using
this operates, see how they use it, and then chat through the changes that they want to make. Yeah, because inevitably there'll be stuff that feeds back into the base that like, hey, you need to fix this assumption here, like the fact that, the thing that Mike found yesterday is, like, why does the octree mesh require the same number of cells in every dimension?
Exactly.
Like, in theory, it doesn't need to, but we bake that in because it's easier. And so stuff like that will just need to be changed. And,
or efficiency. And I'm sure we could gain so much if having like a computer science person looking at the code say, okay, it's not efficient,
So it's something to evolve. I think it'll probably be a slow burn on their side for a bit, but if we get a few more examples of, especially like 3D DC, I think that's something we should try for eventually for all of the methods, is to have like, here's a practical example.
Right.
And with that said, the computation stuff, we should hook that up to GeoSci.
Yeah.
And so even though there's hardly anything there right now, I think if it's visible, we'll hit on it more. Because I think that's going to be a really powerful resource.
So you want to put out an example, like a SimPEG example in GeoSci? Is it the?
Well, there's the computation.geosci.xyz. Right. So I think the SimPEG examples as is fine. Like they're just code examples of things.
Right.
Whereas like the computation stuff is a little more in depth and like explaining what's going on in each step. So yeah, I think having both is fine.
Yeah.
Eventually, we can probably think about organizing, but for now, having one that's like, this is how to run a code, and as an example, that's
that sounds.
So.
That guy. Whoa!
What's happening?
It doesn't like my desktop. Yeah, it's kind of buried right now. Let's try again. Okay.
Yeah, it is buried. You would never find it unless you know that it exists.
That it exists. Yeah. What else is in there? Tutorials.
Yeah, tutorials. I think the leading edge tutorial is on there. Or
nothing.
Nothing. Cool. Yes, it's just the case studies.
Yeah. Okay. I have to give it so right now because.
Well, fundamentals, we have the pixels in their ears. That is the tutorial that's on there. So.
Okay. Yeah. Might need a little bit of that. Sounds good. Cool.
Yeah, because my take was very similar. Because most of the talk is about like in the end part, there's a lot of like lots of data, like distributed array, like a DC. So they diagonal shoebox is working for the company. Their main product is that distributed array. And then using a common reference point, like a physically common reference point to measure a DC data, which is kind of cool. Like that's what probably like most people want, but like they are conceptually building that, but they are actually physically building that as an equipment that they.
It's like a full dipole system then?
Yeah. Well, it's always dipole, right? But
fine, but the other one's really far away.
Yeah, but they always got common reference point. So like a source doesn't really matter for receivers. Like you got 300 receiver, for instance, 300 poles, but they share a common reference point.
Yeah.
So with that, you can make a whole bunch of different combinations, right? Like a dipole, pole.
Oh, right. You just pick any of the.
Yeah. Anyway, so like in theory, that's what we know, but like actually physically building that, there's a bit of detail how to synchronize that. But anyway.
How are they viewing their data? Because I'm talking to someone right now who's trying to process, to invert it, and the QC of it is like a nightmare, because everything is there's no pseudo sections anymore. Like everything is shooting
well,
from
I think
the
remember that contact data, they were just putting in the 3D, and then but like it's not really
cloud basically.
Yeah, cloud based, but it cannot really see, right? Like what does that mean? Right? So you can have some sort of like a 2D pseudo section, but kind of 3D volume. It's hard to QC it, I think.
Could we do like pseudo, like apparent resistivity, just plan view, you know, for all different combinations? Would there be like a transformation that we could do?
Yes.
Yeah.
Well, yeah. So like you can kind of map into
Depth slices.
Something like a pseudo depths and then see how they look like. But it's kind of dangerous because like it could be a little bit like it could be like it doesn't necessarily have to be really smooth in that case, right? Like it's just the data. So they're like depends upon the situation. Because so then like I don't know what you see that and what's your take on?
Just for let's say data fit or whatever, so you could look at planned views of data fits.
Oh, I see.
All right, just to isolate like this area is not fitted well. It doesn't matter if it's a mush as long as you can like your eyes can pick up.
Right.
I don't know how to do it.
Right.
It's complicated.
Well, the easiest way is just generate the 2D section, right? Like you got like a combination where you can generate 2D pseudo section, just for kind of data fed. I think that's what I would do.
Okay. So you slice your cube of data basically.
Right. Or like there are probably different ways. Like, there's a different offset, so you could generate some offset gathers like seismic data and see how that would work. Yeah, this is an open question. I don't actually know how just people are doing that. And the other part was the sensor development. Like lots of they're pushing hard to measure smaller signals, and then particularly for kind of inductive source or inductive receivers, they're pushing hard to measure rather DBT, but B. So they have they are experimenting. And then it seems like
there's one coming out of RMIT.
Right. For a warm system.
Yeah. Well, is it? Well, I guess you could.
IBT.
It was called the ARMIT. ARMIT.
Yes.
RMIT. They're pretty hush-hush on what the technology actually is.
Yeah.
So I have no idea how it measures magnetic fields, but it has something that measures.
There is data.
But yeah, it's ABITB plus RMIT, and then English together you get the name of this.
The actual transducer is measuring B. There's not some kind of thing where they're measuring DBT and then integrating over.
No, I think they're actually measuring.
They're actually measuring B. So they know because you cannot go down that much with that technique because there's a I'm not sure there's high frequency waves and then you cannot really measure below with the DBT. That was my take when they're explaining it.
Yeah, it was more detailed than I did.
Yeah, so lots of that's and then I think what I saw there's the missing piece was kind of software side and I don't know people was it Elliot? I'm not sure, but they were saying now we're at the stage we can formal and then we're the most of types of data, which is probably true, but the missing piece is communication between different softwares and how to really integrate, how to really kind of communicate different physics and also different geological problems or geological knowledge that because it's not a trivial problem, right? And then it's actually really hasn't solved yet. So I think I thought that was a missing piece in that version 17, and probably that's where we could make some impact. We probably need to still working on the piece like these examples, or that example, so that can be a good piece. But probably next step is then how we really integrate to their geological problem. I thought that's important. Research direction.
Yeah. It's true. People have a hard time understanding DC experiment. Imagine when we go to
EM is just too far.
Well, in MT and natural sources, I actually think that's something that
it's a
is going to be. Yeah, there's a lot of potential for it. Like Joel's talk, we saw his sort of preview version of this. Because people are wanting to see deeper. I mean, when you look at Australia, kind of see beneath cover.
Right.
like MT is sort of a natural place to go.
Right.
And I, like a lot of the codes that are out there, I mean, there are some code, like ModEM is probably the workforce right now. But Tiny is something like SimPEG and having all the flexibility that we built in with models and things like that.
Yeah.
Really powerful. And the decomp, like each frequency having a different mesh, all of these kinds of things, even though we don't like have it yet, all the thought process is there.
Yeah.
So,
Yeah.
Yeah.
That's right.
Right.
Yeah, who's working on this? Is there anybody working on this?
Not really.
It kind of it was on Goonies' radar, right? But
Yeah, but Goonies now full-time at SJ.
yeah.
Yeah. Well.
Just slow burn, keep it on the radar.
Right.
It's not like we need to divert people off to it. But
It's true. But playing with DC might be fun. That's what I want to do. Like doing this to magician and generate a sensitivity matrix. like a injury what you're doing, like the sensitivity related that kind of thing. So, make it valuable. And
Yeah.
yeah.
For DC the local meshes, yeah,
Just lines.
that's gonna be like that could speed up.
Oh, yeah, this one's been a lot. And well, so what I felt like what we have is the sounds really good. And for a research code, it's really good. There are quite a few details that we are missing. We need to fill in, and that's probably the right time now. Actually, like fill in that and provide to the other people.
Yeah.
What are we missing? What are you seeing?
Well, first I/O. We don't really have an I/O for DC code.
Yeah.
And then probably simple visualization. How do we could do it? You got some like a survey design.
Needs to be cleaned up. Yeah.
Yeah, stuff kind of. So it's there, but it's not really kind of well integrated, and then we don't really have an example.
We don't have a clean DC branch.
Yeah.
Period.
That's something we should.
We have a lot of branches floating, but
Maybe that's actually. Would you mind pulling up the?
Yeah.
Just the pull requests. Yeah, I think this, and then we can use this as a segue into dev and stuff as well. Because there's just a lot of pull requests on right now, and it's really, which is totally awesome. It's good to see that things are on the radar, but we also need a way to say hey, this is in progress. Don't bother looking at it yet. Versus please review this thing. Because I'm not going to jump in and start helping review until it's sort of
solid.
ready.
Yeah.
Or if there's specific questions and things like that they have. Yeah, so things I don't know, there's the EMIP, DCIP, spectral IP, mag amplitude. Those have just been kicking around for a bit, which is fine.
Yeah.
But I guess maybe one of the things I've tried to do when I've generated a new pull request in Discretize, for example, and I need I'd like a review from somebody, so I'll actually go in and sort of almost do a first pass review myself, and just say hey, this is a weird assumption. Do you think it's a better way to do this? And leave comments throughout the code, because then when I ask somebody else to jump in, it's not just code.
Yeah. It's overwhelming.
Yeah.
That's
Especially when it's a big refactor or a big contribution of IP or of ERM. When there's a brand new method coming in, it's a lot of stuff. So.
And so you do it in the on the last commit, I guess. You start adding notes on it.
No, so if you scroll up and you go to how fast change.
Right, of course.
That's where I would do that.
Yeah. Just slice and the comments wherever you think.
Yeah.
That makes sense. And as you see, I haven't installed Code.
Yeah, so, and then Dom, you've been working quite a bit with the GitHub project.
Yeah, so we could set it up if you guys want. Basically creating, well, let's look at how it looks for JIT tools. But the neat part is that you can start, we could basically create a project for physics or something like that. And then after that, what I own is pretty light, but you can have in progress, and you can move these guys and review and want review on it.
Right. I think that's actually much better.
It's just to keep track of your tasks, basically. And then issues can be put in those, can be ranked there too. So that's kind of an option, I think, for us.
I think that would be awesome.
It's very light, right?
Yeah.
I mean, it takes 2 seconds to set up, and then whereas SimPEG. Do you know how to how to customize your? So annoying.
I have no idea.
I
I
just want
generally
them.
just like, I hit the same GitHub URLs all the time, so I just like start typing SimPEG and it just takes me.
Gotcha.
So,
Yeah.
yeah, I think it would be very helpful.
Yeah, I can set it up. What about one project per physics? That works. Like a one static, one time domain, one FEM.
Yeah.
And then move the issues to each.
I think that works. We might end up needing projects for things like directives and IO and whatever, but let's maybe just start with the physics.
Because yeah, it's true. You're right. We could almost. Where are you? We could almost use that tree, right? The SimPEG tree.
Actually, one of the things that I brought up as an issue with respect to the tree, I don't know if you guys saw that, was flattening the API a little bit more. So instead of having, because right now, like to get to the DC code, it's like em.static.dc.
Mm-hmm.
Nobody's going to think of static, which is fair.
Nobody actually like, well, there's probably somebody, but like most of the people wouldn't think about EM, then DC.
Yeah. So, okay, what I would potentially suggest in that case is that we still keep it inside of EM, because I could see us actually pulling EM into like its own standalone package at some point. But we could actually alias it so that you can import.
SimPEG.dc, and
Yeah.
you don't skip it.
I like that.
Okay. So, yeah, I'll make a note of that in the issue, and if somebody wants to like take it on and start hitting on it, that'd be good. But we'll, I guess, need to get the other pull requests. Or like, I don't know where DC, the most recent live DC stuff is.
Oh, it hasn't been really updated that much.
But like, is it on that pull request or is it on dev?
Which one? Sorry, what are you talking about?
There's like the DCIP, special IP.
Oh, that one is not, that one is not in dev.
Okay.
But just DC and IP should be.
Yeah.
Should be there. There are a few minor changes, but like.
Okay.
Into that.
Okay. Cool. Would you like to jump in?
Yeah.
Do you want to maybe join the hangout and just mute your mic and then you can screen share?
Yeah,
If you'll need to add as a person.
oh, yes.
So, do you?
Or you can just send them just copy the link
Okay.
and send it on Slack.
You're going to Google Hangouts?
Yeah.
On Slack, I put the link.
Yeah, my camera might not work.
That's fine.
You just share your desktop, yeah.
Was there anything else you guys wanted to know?
Well, maybe a small one. You're actually starting to provide DC 2D and DC 3D examples.
Already a pull request for 2D and 3D example, and it passed very soon. Like what it doesn't pass is like possible.
It's coming straight out of dev, right? It's not building.
Yeah, it's
Perfect.
coming from there. Like I just forgot the storage at some point for the 2D example, which we removed it.
Yeah.
And then it failed once because it needed a dot string at the beginning, but I had it yesterday too, so like it's like these two examples are almost good.
How come Code Co-op is not happy with examples?
So it's, if you look at the pull request, it doesn't actually change.
No, it's like super small.
So, because we don't actually have coverage on the examples, like that's not included as the
Yeah.
coverage. It shouldn't actually be included for the stats, but we might have that on. it's set up correctly.
Oh, okay. So it's technically looking at it as if it was base code.
It shouldn't be, but it might.
Okay, okay.
Because it should just be like ignoring that punter code.
Yeah.
But I actually think that the lost coverage is with your util.
Yeah,
which-
yeah,
that's
exactly.
fine.
I added an option to the generate DCIP survey. So now you can add the option that it's going to be a 2.5D survey. But I didn't create a 2.5D example, so it's not tested.
That's fine.
Okay.
That's good.
Cool. You going through Google Hangouts?
Yeah, join Hangout.
Slack. Dom said she would on the SimPEG Slack.
SimPEG Meeting. Yeah.
Can you just make sure your volume is on?
That's all.
So where's the data and mesh and stuff?
Ooh,
Can you put me?
Well, that'd be a really cool example that I took a computation.
I'm a little scared how long it's gonna take. That's fine though.
But like if something comes out of it.
there's only 10 lines, right? I mean, if we can get through it, then we're good to go, man.
Yeah, well, so I think I went to test and then.
Yeah.
So I think it'll be good. I think so what I thought was in case I would just like compare the BBC code and kind of exactly matching,
Yeah.
kind of take that types of things.
Yeah.
We can like calculate.
I have
But
it
yeah,
on.
before we actually like kind of provide them, I want to make sure that's actually kind of in good shape.
Yeah.
Otherwise, like it's very easy for them to disappoint. Oh, it's not.
Yeah, it's pretty big, but I can transfer most of it. How's your Dropbox? Can you hold? Yeah. I finally bought the terabyte because like
Yeah.
I'm tired of.
Yeah, I haven't bought it, so it doesn't matter.
Perfect. So I'll clean up the project and I'll upload it to Dropbox.
Right. Yes. Just I think just mesh observation topology. That's it. Really?
I'll transfer what I have so that we have somewhere to
Right.
play around. This makes no sense that it's only sitting locally, but actually that's the thing we need to figure out with Doug is we have a lot of case studies and we want to start bringing them in,
Yeah.
So Sarah kind of did a cleanup and Chris had some on his computer that is kind of scattered. We need to bring them all into like the UBC umbrella. But whatever happens to UBC later, they have access to what we have, right?
Yeah.
Yeah, it's not gonna work. I've installed the plugin and then refreshed it.
Are you on Chrome?
Oh, shh. That's why.
Chrome.
So some of these are private, some of them.
Well, I mean, I don't think this matters when we're internally because they have been all been given to us. Maybe we can flag like these cannot be distributed or whatever, but
Yeah.
this data is actually all UBCs.
Yeah. Where does that all live right now?
There's some on this computer, some on this computer, some on here. That's the issue. Yeah, we need to bring them in somewhere, and it's going to be pretty bulky.
Yeah. Dropbox. We should get even corporate Dropbox account or something like that. Right, like the own stuff.
It sucks. Yeah, it just doesn't do it.
Well, what we could do, we like can kind of parse it out, like what could be open pieces, and can we move to Google Cloud? Is that
Yeah, we can move stuff to Google Cloud if it's, but like,
There's some of it that won't have it all the time.
yeah.
It looks like-
I mean, and we can source it privately on Google Cloud, but it's not like as easy an interface.
Yeah, it's off.
Oh, I can't hear that.
Yeah. Okay. And then- Yeah, because so like the Google interface just isn't quite as easy to navigate and like update permissions and stuff like that. It's not bad for like if you just want to like the way we're using it right now is we just have stuff up there that you want to hit and download. Like that's really
Easy.
like, a good thing to do
Yeah,
there.
yeah.
And so, yeah, I would think like a first pass thing would just be like get a
A private account.
Dropbox account.
Yeah, $12 a month, whatever.
Right, so I think I'm basically good to go. Before I get into the nitty-gritty details of how I set up the code, I kind of want to give you guys like a 5-minute reminder of what this code actually does, so you guys understand why I'm formulating it the way I am. So let's say you got sort of a true VRM response on sort of a log plot would do something like this. But I found that over the range of time channels, which we measure time to median data, we have an approximation to that decay. And this lets us predict the fields according to a linear equation. So where n is the model parameters, maybe, I don't know, maybe this is my domain, I've got some kind of topography, maybe I'm only interested in the top whatever meters of my mesh. Basically, I don't want to forward model air cells, and maybe I don't want to forward model cells in some distant part of the domain for whatever reason. So I've got a projection matrix that goes from the cells that I do want to measure, maybe in this region, to, and then, yeah, so from maybe, yeah, all the cells to the ones I just want to forward model. And then I have this A matrix, which has all of the geometry of the problem, all of the like transmitter and receiver relationships. So this is really dense. So I don't want to create this for all the cells. I end up just wanting to create it for the cells that I've deemed have VRM. And then T is this, we call it the characteristic decay matrix. But depending on the number of receivers, the different time channels I want to measure this at, whether I want to measure like H or dBdt, it's going to populate a very sparse matrix T. So when you look at this, you realize it's a linear problem, and we have a framework for this. However, the more time channels you use, the more difficult it is to store T times A. So with the current SimPEG framework, I can't just store the linear operation. A bit of a thing I had to deal with. It's a time to median problem. However, there isn't time stepping. There isn't computations of right-hand sides and things. So I didn't want to develop my class and have it as being sort of a subclass of the time to median stuff. I didn't want to put it in that folder. It was really important for me, and probably for users getting used to SimPEG, that if I made some kind of class and I built it off of some superclass, all of the functionality that I want for this needs to be in this. But at the same time, I don't want redundant functionality or redundant operations that I'm allowed to call that don't work for this class. So I put the VRM in a different folder. So that was really important to me. One example is the right-hand side. I'll have some mesh attached with the problem. I'll have some transmitter, but there's no need to compute the right-hand side. So just want to be mindful of that. The other thing, which maybe is a third point, is if we have some kind of time to median problem, we typically have sort of an EM response, and then the VRM does this. The whole point of developing all of this was that we wanted to invert just these time channels, predict the data everywhere, and then subtract it so we could isolate the EM response. So although I want to be able to predict data at all the time channels, when I look forward to the inversion, there's going to be sort of an active set of time channels. I only want to invert sort of the later stuff. So I've been working on that.
Can you tell me now again what's the P? What does the P matrix do? The projection is what, from where to where?
This is yeah. So if I've got M, let's say the model parameters, or so yeah, my model is defined on the entire mesh. This will basically, it's a way of sort of just using a projection so that you're only using the cells that have defined as like a VRM response.
So your linear operators only for that layer.
Yeah, you can specify it. And I know that we have an active cell projection. For various reasons, I'm using both and like a topography projection. It's just a way of reducing the size of A in certain situations. The way I define things in the code, you don't have to use that to KW args. And if you don't care about it, it'll just be an identity mapping. You don't even have to worry about it.
So one quick comment on that is I think that actually that P matrix, I mean, it really is just a mapping. It's not a mapping.
Yes, and it's defined as a mapping object.
Right, but the way that that's passed to the problem, I think can sort of like follow the very standard SimPEG way we pass mapping, so it doesn't have to actually be a keyword argument. It just like comes in as a map.
Yeah, like I don't construct this explicitly and store it in the problem. You basically give it a topography mapping. So I'm using the mapping.
Yeah. It's just a question of how you interact with it, and I'll make a note on your pull request because I think that this clarifies because I just had a quick look at how you like instantiate your problem class, and so I think that the way that the mapping is passed can just sort of follow the very standard way that we always pass a mapping to a problem. So it doesn't have to be treated separately or anything like that. So even though it's its own like distinct style of mapping, it can still be treated in the very sort of like SimPEG way.
Okay, I thought I was doing that by, instead of explicitly forming this,
Yeah.
it was defined as a mapping object.
Yes,
So,
yeah, absolutely.
okay.
So it's just, there's like one more step in the way that it's instantiated
Okay.
to make it just a little more uniform, but that's absolutely like the right way to go.
There's just a little nuance though, because if you import it as a mapping in your problem, and then when you're going to take your derivatives, you're going to take the derivative of the mapping. But in this case, he never wants to expand back to the full space, right? He always wants to stay in this reduced space. That's why for the PFs we were sending, we had an active flag or like
I had to
index.
do the same thing for like, so in like storing sensitivity.
Yeah.
Like you don't want to store sensitivity in the air cells, for instance. You only want to store
What you can
where your
convert
vol
for.
is defined. So so I had a mapping for a property.
Yeah.
I do have a mapping for active cell. For
Okay.
instance. So I think that's probably what they're going to end up doing, I guess. And that's kind of natural way to implement that.
That's right.
Yeah, that active, I looked back and kind of was seeing what stuff I would need and how it's supposed to be implemented. See if I can explain this right.
Can I jump in?
Yeah.
End active or active end. We need to be consistent. We're so inconsistent.
I'm using active end. I don't know. I think regularization is inactive, right?
Yeah.
I'm totally fine with
No, like it doesn't really matter. It's just like we should stop calling it two things.
Sorry, so we were going for act end.
So, like initially, why I called it end active is just like because if you're tab completing end, it's like indices. So that's like a thing that you're looking for rather than active, which is like a descriptor. So that would be
A counter argument.
Yeah.
Well, I was using act end. Yeah.
I think I wasn't very consistent, I guess.
Me neither.
Yeah.
Sure.
I think
Let's.
that's just gonna like come back and bite us.
Sure. So what did you decide? What do you?
I just use error things.
Yeah.
Because most of the times my inactive cells are error cells. So
Yeah, but then you G positive. You usually have positive for ground, so it's not your air cells, your ground cells. Right?
yeah, so I think I use it till this. So.
Oh my God! No! Air cell, the non-air cells.
Yeah, it's fun. It's really good.
Well, yeah, that's
Okay,
true.
inherited that
We should
so.
be stricter.
Yeah, let's, because what we could do is like, because Mike, in your case, it would also be helpful then to have inactive, because that's what you want in inactive.
What doesn't matter. I'll be fine. Go ahead.
Okay.
We will have format.
Um,
What makes more sense?
we can,
We can vote.
yeah, go. Like, I, on the tab completion side of things, I would go for inactive.
Get active.
But I can be convinced either way. We can like mull it over and vote and then fix some things.
Let's vote.
Yeah.
I agree with you on that one. Yeah, I guess it makes more sense that the object, like the thing that you're looking for, is an index and the descriptor after.
Yeah, because I think that's like also what we've tried in a lot of utils and stuff like that. Is like, try and start with the most natural thing and give them a look for.
It's less English. That's the, you know, it's less spoken to use the in first, but. Okay.
Yeah. But yeah, the way I set up the active cells as it is now, it's based off of how you would do it from like the base problem class. I didn't make an extra layer of things. This was really just to call an operator to reduce like computational needs, and if you don't need it, it doesn't matter. But one of the big examples for this is if you did have a topography, you would need to do something about it so that if you had some kind of transmitter receiver position here, you can't be forward modeling cells that are, or forward modeling locations that are inside cells, right? It's a potential fields problem. So we need something for that. You know? That's sort of how I did it. But I've defined a physical property that I'm calling C. I think I'm defining it as this. And I have like C, C map, and C deriv. So I'm using the same as much of the framework as I can from the base problem.
What's C?
Yeah.
It's how, so the actual physical property comes from a log uniform distribution of time relaxation constants that defines that decay. And I invented this, let's see, if we go, let's see, the susceptibility is something like C naught plus delta this over ln tau 1, tau 2, and then some other stuff. And I was able to make this amalgamated like viscous property. It's delta chi, so sort of the amplitude of the viscous effect over all frequencies divided by ln and tau 2 over tau 1. It's just sort of this amalgamation of a few parameters describing magnetic viscosity.
Does it have like a meaning? Or
Yeah.
is this something?
This? No, but something that's more English, you know,
Yeah.
because
Well, I called it like, I think in my thesis I called it like an amalgamated viscous property or something like that. There wasn't really a name, it doesn't exist.
Yeah.
I had to invent it.
So that's a property M?
My physical.
That's what
yeah. So maybe I'll write out the whole thing. So let's see here. Susceptibility is not plus delta chi 1 tau 2 over tau 1 times. I think there's like a 1 plus I omega tau 1 over. There's something like this. This is something similar to what the formula is for magnetic viscosity.
Can we call it parameter? Parameter.
Yeah, so under, basically the response was ended up being parameterized by the magnetization during the off time was equal to some time-dependent function times this. Tau 2 over tau 1. So this is the mol parameter that basically this is a constant that defines the decay of the VRM response.
Okay.
So it's not a physical property like conductivity. It is just a single parameter which I can use to define magnetic viscosity over those times after the transmitter's been shut off.
Would calling it something along the lines of like a pseudo VRM Or
Yeah, you can give it a real name. I'm just saying, in terms of a symbol, I use, so instead of having like sig map or mu map, it's
Yeah.
c map.
yeah,
That is the variable that I'm using to be distinct in terms of how I call it.
Yeah. Yeah, and so I guess like with, because C doesn't sort of lend itself to figuring out what it is for physical property. And so like what I would recommend in this case is that we actually try, instead of using C, like pick something that actually is quite a little more descriptive. So that when you like read it, you at least have an idea that it is some sort of like amalgamated VRM physical property.
Yeah, well, there should be background documentation that would be defined in there. We're going to show what the problem actually
Yeah,
is.
but for reading the code, we don't want to have a C letter because it's so like ambiguous. You know, we don't want to start using A, B, C, D, E because like.
Well, I guess all the other physical properties get a Greek letter, so I decided to give it a Greek letter.
But C is not a Greek letter.
Well, ecstasy.
This
But that's not
it's
the,
called sigma.
so like
Oh,
what we've
sigma.
actually called, I mean, when you say sigma in with respect to like, electromagnetics, it's pretty.
Yeah, everyone gets it.
Yeah.
But I think whereas here, if that's just a Greek letter that like you've defined for that, it's not going to translate easily to anybody else who's looking at the code who's not deeply ingrained in the way that you approach this.
Yeah, but for the linear VRM class, it's one of the first things that's defined. It's defined as a property, an invertible property.
Yeah.
It's the physical property that is associated with that. Feeling that with some commenting, and if you understood how to work with the SimPEG code, it should be pretty obvious that that's how I'm defining my physical property.
Okay.
Like I don't like, you could pick another couple of letters. Maybe you could call it like VRM map, but then you picked 3 letters that, unless you know what you're talking about anyway, would also be confusing. Like I'm not seeing like a better option for something like short that I can use to describe this physical property.
Yeah, and I don't actually think like being short, I mean, we don't want to be like overly verbose, but I don't think being short is like the first priority. I think of this for now and like give it some thought. But yeah, I think like one of the things that I've certainly experienced, and I'm not sure if others have as well, but like when exploring an API, I don't read documentation. I like create an object and I do .tap, and then like, what can I do with this?
Yeah,
And if I see C, I'm like, okay, what is C? So that like just sort of helping facilitate that sort of interaction, I think is actually important in terms of like making SimPEG very interactive and something that you can just explore and play with.
That's why I use these guys. Display stuff. I mean, I think that SimPEG doesn't use, like, it doesn't give you as much of a comprehensive sort of thing, or maybe some of the methods that we have or objects we have, like, we haven't had the time to go in and be really thorough with that.
Yeah.
But
you understand our point, right? That you should be able to, like, someone from the outside not have to read the string doc. Like, you can understand what it is right away.
yeah.
What your model parameter is, since you made it up anyway. It's up there.
Sure. Yeah, I guess when I was assuming that if somebody didn't know what like C map was or what C as a physical property was,
Then you
that
would
if they went, object.c question mark,
Yeah.
it would print that out for you and it would tell you.
Yeah.
I guess that's how I was hoping to get over that hurdle. So I'm sort of trying to think of what do you call that variable that it's not a sentence, so just a few letters, that you would do a better job. I mean, if you come up with a better idea, then I'd be happy to hear it, and if you guys think that's the way to go, then for sure.
Okay. Yeah, that's something to definitely think about, and I agree the docs are absolutely essential in like that next step, but if we can sort of do something to mitigate it in between, that's all.
Okay. Yeah. So that's pretty much all I have to say about the background physics, but that's sort of, these sort of details are pretty important. It's a linear problem, but we can't just use the pre-existing linear framework because we want to store T and A separately. It's a time domain problem, but we don't want to use a bunch of redundant functionality. And some of the stuff with the receivers is different. And then we are going to want to invert a subset of the time channels. So whereas fields is going to be this thing, predicted is going to be some kind of either like a projection matrix or something that grabs just the time channels that you want to invert.
T is for time, am I right?
T
or,
is
like a time dependency is only coming from n or p.
Yeah, this is all of the geometric relationships between the transmitter in the cells and the receivers in the cells.
Got it.
And T, I'm calling it the characteristic decay matrix, where if the magnetization is just some purely time-dependent function times a small parameter, then you have this sparse sort of block diagonal matrix that's populated with this sort of decay behavior, like the time-dependent function that you said.
So A is reused for all of the.
Yeah,
It's the same.
Yeah, so you do one matrix vector product A times M, depending on the different time channels and whether or not you want to measure B or dB dt, then you do a sparse matrix vector product and just spreads it out and gives you everything.
Mhm.
That was sort of the computational benefit of doing this.
Yeah.
That was why we decided to do it.
So I have to run, but you guys feel free to continue and I'll catch up and watch the rest of you.
Roger that.
So I guess I'll show you guys a little bit of code.
Yep.
Maybe I'll plug in so that.
Thanks for being here.
You're welcome. Okay. So now I gotta do sharesies.
Gotcha.
Okay. So maybe I'll talk about the file structure a little bit. So I use, I think I use the time domain EM stuff as my inspiration for how I wanted to organize the files. When I looked at that, I just, even though I was really new to SimPEG, I knew where everything was. I knew that this is where I was going to find all the stuff about the receivers, right? And so I did it that way. Maybe I'll show you what I did in Python, if you actually wanted to use this. So obviously you would make a mesh. This works on 3D tensor meshes and 3D like the Optry meshes. So you can use both of those. You would make some kind of model. In this case, I wanted my topo, basically my topography mapping. I don't want to use any air cells, so I made it accordingly. So I made a maps object, and then I defined the problem. We have these two parameters called ref fact and ref radius. And when I found that there needed to be some kind of sensitivity refinement. I don't remember if you guys recall from the thesis defense, but if I had the fields are changing spatially, they're not broad, they're not smooth, very near the transmit. If I have a dipole source right over a 2-meter cell, or I've got a wire right over a 2-meter cell, the sensitivity of that cell to the data, it's incorrect because the inducing field is changing that. So there is a sort of a refinement of sensitivities for that cell. It breaks the cell into a bunch of small volumes, and sort of recomputes the sensitivity and then replaces it.
Yep.
So there is, you don't have to put them in, they're KW arguments. There's like sort of a standard that gives you a fairly good numerical accuracy, but you can change it. You can also put in this topography mapping, or you can not put it in. It'll just be the identity matrix. And then we have our C mapping that either starts out as this would also be an identity mapping. So these are all things that you can go and change for the problem, but you could just have a situation where you don't have to worry about it. These aren't necessary. The other important thing that you then have to define in this case, which is a bit different from some of the other problems, is you have to define the waveform. So that function f, that time-dependent decaying function, the things that populate that T matrix, there's a certain function that's defined for step-offs. There's a certain one that's defined for square pulses, and then if you want to put in an arbitrary waveform, there's something for that too. So you have to define the waveform that's being used. Then you set up your receivers. So depending on whether or not you want H or dB/dt, you define your receivers just like you would with some kind of time-to-medium problem. And then you set up your sources in the same way. So transmitter list, right? So it's a VRM, it's a source, it's a line current source. You put in the location, the nodes, the current, and then the waveform. So pretty similar flavor to what you have for a time-to-medium problem. And then you couple the survey with the transmitters, and then you can either choose to or not choose to set the range of time channels that you want to invert. So if I was to do that later, maybe I only want to invert everything that's after 1 milliseconds, because that's where I'm seeing the VRM response dominating. You can set that.
Like, is it kind of natural? What I would think is like you just pass the time channel that you want to invert rather than an interval. Is that like natural to do?
I set it up to be versatile in the sense that what if somebody was a crazy person and decided that they wanted a whole bunch of like different transmitters with different waveforms and different receivers, and they wanted to like measure at different time channels. It has to be able to accept that scenario.
Yeah, sure.
So this was, I mean, if I put in the individual time channels, then I don't know, I'd be looking for matches. I just found that the interval made more sense. You could just put in 2 numbers and say, I want to find all of the places where I'm getting responses between this time and this time.
But like then what's your data? Is that 2 points or like is multiple time channels of data?
You will, if you look at the difference between fields and D predicted, there's that P sub D. There would be some kind of projection matrix that would take.
Oh, I see.
Yeah.
So like you're still like your data is just one point. It's not a time. Am I right? It's not a multiple time channel.
In the thesis, I did that whole collapsing thing. In this framework, I can't. So I only want to, like I basically whatever I'm doing here, I have to end up putting it in the SimPEG inversion framework. And my solution to that is that I pick the range of time channels I want to invert. And so D predicted and D observed and all that stuff will basically map fields to data using like a projection matrix. It's exactly how all the other codes would work.
Yeah, so my question is like your data is multiple time channels or not?
Yeah.
Yes or no question.
Yeah.
This is multiple time channels.
Yeah.
So all
So
the time channels in between the center, the loud and center.
Yeah, so in this
Oh.
case,
so where do you define your time channels?
active time interval. Well, the time channels
Oh,
where
it's
the
there.
receiver, yeah, so
I
it's the
see.
same thing that you would define.
Oh,
for
I see. So
receivers.
you want to grab like a sum part.
Yeah, so if I check fields, so in this case I have 3 transmitters, each with 1 receiver, and each of them measuring at 3 time channels, right? -4 to -2, 3. So I got nine total data. But then I defined that I wanted, well, so this active time interval here is, it's only going to take the middle of this. So if I go D predicted, it's only this piece of data, this data, and this data fall within that interval. And so I'm only going to be inverting those data. And this was this was my solution to being able to then pass what I'm doing to the pre-existing SimPEG framework and have it actually work.
Right.
Yeah. So I tried to make all the syntax the same, survey.make synthetic, like this is a method that was defined in the base survey class. I didn't make this. So I'm trying to use any super class that I'm using to base the VRM classes. I want to be able to use all that functionality and have no redundant functionality. But you can do the same thing, right? So you can pair the survey with the problem, predict fields, unpair it, all that stuff. Put it in, and so then the last thing that maybe I want to go over, unless anyone has any questions up to now, is you're going to store this T matrix and you're going to store this A matrix. But one thing about this problem that's unique is that because it's potential fields, you can use a method of equivalent sources. And you're going to store that T matrix in that A matrix. But when you call it, you want to be able to call the thing. And if you change your topography or your active cells because you're doing a method of equivalent sources, you sort of forward model the data using a bunch of cells, but then you only want to use a subset of the inversion. It's smart enough to recompute it when it needs to. But all you have to do is call it once. So you don't have to like add a bunch of stuff. You just say, give me A, and if something changed, it will update it for you. And that was done using this add properties decorator. So yeah, so you can see C, CMAP, C-deriv. These are vertical properties for the problem. So I made a sort of a secret attribute underscore A, and I call the property A. So if I was like problem.A, if I set it, or sorry, if it's not set yet, it'll check if I've paired the problem with a survey, and if it's stored something, it'll delete it, so I'm not storing two things at once, and it'll compute it. But if I've set the thing, it'll just return it. Yeah, are you guys following? Like, I think I'm kind of rambling a bit now, so is there some sort of...
Yeah, so why are we passing? Is your topo map, that's what we're just talking about. Your topo map, you're only doing that transformation every time, but you don't need to, right?
I could call...
Like for instance, line 9507.
I could do, I could go problem.A, and because it's a property, it's going to call the sort of the getter function. So this is a getter function. It wants to get A, and I have this flag here that says if I've already gone through the trouble of computing it.
No, that's not what I'm asking, Dale.
Yeah.
I'm asking about your tuple map.
Maps.
388, yeah. Right? So you're only using a tuple map to grab your indices.
What am I doing? Yeah. Table index.
Yeah.
Yeah.
And then 509 and 507, you're always doing a projection. You're always grabbing your full space and reprojecting. You technically could only do that at the end of everything, right?
Is it 507?
507. Like you don't need to do that operation here every time. You're doing it here. You're doing it at 489.
Yeah.
You don't need it there. Because you're already reducing your space. So work in a reduced space all the way. Invert and reduce space, and at the end, if you want to bring it back to full space, then we do it outside.
The A is the most compact that
that's right.
That it can possibly be.
That's right.
So the story I'm happy with, but then yes, it's true that
M doesn't have to be full space. M could be only the size of your A.
Yeah. Well, that's what we usually define. Right? That's how we usually define.
So you will skip yourself to always call this mapping, do the transpose every time you do the matrix vector product, because you don't need to do it.
I could combine the piece into a single.
No, you don't need to project. You don't need to reproject every time. You only work in a reduced space. You do everything, your inversion, your forward, everything in a reduced space. And at the end, when you output your result, then you do your.
I think one of the reasons I did this is if we, let's see, if we had, what was the reason I did this? I think right now, there was a reason I did this.
I'll think about it, but I'm like 100% sure that you don't need to have it as a mapping.
I think
You're doing more operations that you need to. M doesn't need to be your full space. It's only your active cells.
Yeah. I think part of it was ease of being able to go and then, I don't know, plot the model easier for some reason.
Yeah, but that's what I'm saying.
Yeah.
The plotting action, you only do it at the end when you're done, right? So you don't need to do it inside here. This is going to be much more efficient if you don't need to always cause a transpose and bring it back every time.
Yeah. No, I do agree that you're doing these two multiplications with projections, and there's ends up being a bit slower.
Because you're going to do that often, right? 8 times your model, you do it like in your CG constantly.
Mm-hmm.
So you don't want to have to do that operation.
Yeah, I'll think about it.
Think about it.
Yeah. I do, ultimately, I do want to have, for every, I do want to have this like topography mapping and have this active
That's fine.
mapping.
Yeah, that is fine. But just like M, like consider M is defined only in your like, active domain. Right?
Yeah.
Where forming a specific.
Because the active mapping, it like you can parameterize it. So what if I want to invert for, say, a layer?
That's 2 things. Yeah, it's your,
Yeah.
you're going to have a mapping for the reduced model space.
Mm-hmm. So you're saying I basically have to combine the two?
No. Like you can have a mapping right now. You're using an identity matrix for this part, right? But you could have different mapping for that layer. You could parameterize it with whatever you want. But I'm saying you don't want the other mapping that takes a full space and reduces to here, because you don't need to do that every time. You only need to deal with that layer. So don't do that operation every time you want to touch your model. It makes no sense.
Mm.
Makes sense? Does that make sense?
I did want to have an easy way though to whatever output I got to be able to turn my model and project it to the full space of the mesh, so that I could then.
But it doesn't need to live. It doesn't need to live inside your code.
No, I can. There would be a faster way to do it. This was just sort of an easy, straightforward way to.
And it's much more confusing to read this when you always have that transpose, that projection transpose every time, and it serves no purpose.
Yeah. No. Yeah, I agree. So there's a faster way to do it.
Yeah. Anyways, anybody wants to say anything else, Mike? You are complaining about the arc-tree dimensions. Rowan replied to it. It's complicated.
I mean, that's fine. It's not a big deal.
Yeah, it says it's baked in pretty deep, so we'll need more dots if you want to. It would be nice, but then.
Did you finish the issue that we did a few months ago or a couple of months ago about the whole arc-tree mesh when either you plotted it or when you were running it, it was shifted over?
Yeah.
Recognize the bottom.
You fixed it.
Yeah, I fixed it. It's on my branch for the grad. It will be brought in once I finish the tests. Yes.
Super.
It's the whole thing that there's a difference between when you call cell and when you call grid CC, something like that. So cell is always not, there's no origin on it, but grid CC is origin. So it's just
Yeah, because the bottom line, when I wrote this, we're going to store A and we're going to store T. And if you were to change something like the active cells, like change dependency of A for any kind of reason, then all you'd have to do is problem.A, and it would recognize that you changed something and it would reform the A matrix for you.
Thanks.
So maybe this is a good segue into the properties thing that I harassed all of you about, because I figured it out, and it's really handy. So I guess let's say that upon initializing an instance of your class, you wanted to create some property. We'll call it X. And it may be a KW argument. It could be something that has sort of a, if you don't bother playing with it, it gets a default value. But if you wanted to, you could set it when you're doing an instance. This thing, it won't call any of the stuff below. It's sort of independent of that. It will, the way that I've written this little script, it will, yeah, it won't take any of the properties into account. Then when you define a property, let's see if I should put restart. Open this guy. Basically, I want to make it so that if I want to call this variable, I want to initiate maybe some conditions. Maybe I want to print that I'm getting this property, or maybe I need to compute it. Or what I did before is recognize that if I change this topography object, I need to recompute the A matrix before I give it to you. The setter will put some limitations on what I can set it. So I don't want somebody going problem.a equals some garbage. I can, by setting the setter or not putting a setter whatsoever, I can make it unallowable for somebody to change that. Or, and then you can also put conditions on deleting it. So I'm like this guy. From so I set C. There we go. And let's see what C is. C dot X. For C data. I guess the bottom line is we have a scenario where we have some property of a problem, some attribute. We would like the option of being able to set it or give it a default value when we initialize the class, like create an instance of the class. And then we want to basically be able to control the getter. So when I go instance dot that property, it will call everything that I put under here. It'll carry that out. Put limitations on what I want to set it. So a NumPy array, I don't want to be able to set it as a float or a string. I want to be able to do that. And then if somebody wanted to delete it, you could either make it impossible or that it will go back to a default value. Basically, I want it so that if somebody doesn't know what they're doing, they can use it, they can call the property, and everything's happy behind the scenes. But if they don't know what they're doing, they can't screw it up. There's a protection to this property. And that's kind of the point. I think I'm going to need probably 5 or 10 minutes to sort of remember how I did that. But this was the way that I found to be able to do it, to set it up using a KW argument, so that when you're initiating it,
what's the N1 flag?
Yeah, the N1 flag would be if that means that I could go something like
that's not Python, that's you. So what
E equals C N1 equals P. So that
Oh, I
N1,
see.
N1 is the flag for the KRs,
Okay.
and 3 is the default value for that.
Gotcha.
So, yes. Set it that way.
Just p.x, do p.x to that. Because you did c.x, and that's just a fun, that's a property.
Yeah. Self.x. Oh, that's why. Okay, yeah, that makes sense. Okay, we can actually do it. So we'll go. And then we'll go C N1 equals 2. Yeah. Okay. All right. So we'll do it side by side. So I initiated an instance of the class. In this case, I went N1 equals to 2. So I, instead of having this default value, I did it. And because I'm calling the init self.x, I've called the setter function. And so that's why it's saying set as 2.0. So then if I did get x, it should return that. So p.x.
Because you did c.x before.
There we go. Get x gives me 2.
That works, man. We all agree with this.
Yes. So this is like a thing that I've decided. This is basically why all this crap works. And it's super, super handy.
So I'm just like, I left a comment on the pull request just showing the properties library, and how you can use that instead of doing the, well, it sort of augments a bit of the setters and also makes it a little more clear where your assumptions are. So setting the minimum value, for example. So saying like conductivity should not be A. It's a little more transparent when you do that through the properties library, just because of the way it's documented and like its input as a keyword, or like its input as an argument when you define the variable. Under the hood, it does all of this.
Yeah, that's what I figured.
But in a little bit more of a transparent way. So in terms of just like code readability, I would highly recommend just taking a look at implementing it.
But what if it's a matrix or an array? And then I guess when you're doing this properties business, a KWR score like is instance, I guess, and then
So there's, well, so you don't actually have to do that. There's actually a properties dot. If you have to look at the properties docs, there is a list of types that you can have. And so if you look in, I'm just gonna send you.
I mean, yeah, and I look at other places in SimPEG and they don't use it, they use this too.
Yeah, exactly.
6 and 1/2 doesn't get it.
Yeah, and so we're trying to move more so towards the properties library, because it just like takes care of all the documentation and makes validation and all that much more transparent.
Okay.
So not all of the code base is called
We
out
need
to
to
that,
start to move out.
but if we can sort of like try and make a habit of that being the way that we implement things. So I just put a link on Slack with the built-in property types. And so that shows things like, so if you look at, for instance, the math properties, or the even primitive, primitive properties and math properties are probably all that you would need. So those are actually probably too involved for much of what's necessary. So bool, integer, float, complex string, and then math properties array. That should actually take care of most of the things.
Yeah, it would for most of it, but for this problem it might not. There's sort of a flag that I have, and maybe there is a way to do it. I mean, I haven't looked at it yet, so I don't know for sure. There is.
for dimensions with those. Let's say you want to make sure the dimensions fit. You would just add an extra layer.
Yeah, so if it's a float, it needs to be one-dimensional.
Yeah.
But for arrays, you can give it a shape, or what Franklin's recently implemented is I believe that you can do a list of shapes, and it has to fit within. I'll double check because I was asking him for some funky stuff with respect to that. But if you look at the array properties,
Where'd you see that?
under map properties.
Oh, okay. Oh,
Yeah,
right
so
on.
look at an array.
Yeah,
So
okay.
it takes a shape, a D-type, so you can say that this array should be floats, or this array should be full of complex numbers.
Okay.
And then you can say, because one of the things I did ask him to implement, I forget why, but as I needed a 3D array. And so now we can take 3D. Yeah, so what's kind of cool is the way that this is set up. It auto documents all of your things, and it makes the code just so readable. So I'll show you the. Actually, or even GeoN.
And well, I mean, you're defining the property, but through this, are you also defining the getters, or sorry, the setters and the deleters?
Yeah, so.
I mean, because I've got sort of a flag here. Sort of like A is set, and when you change some things, it will change the flag back to false, and it's check for that flag. I'm not sure how it's going to line up with the properties.
Okay.
I guess it doesn't, in some ways, it doesn't have exactly the same feel as a SimPEG style property. It is a VRM specific property.
Which is fine. I'm wondering, because I think we're getting into the weeds a little bit here. If we want to kind of pull up and go a little more high level and just talk first about how do we want to facilitate sort of continuing these conversations within the pull request, how we've done that in the past, and just how to move this conversation forward, because I think we could spend hours sort of talking about this right now, which we don't have. So,
Yeah.
do you mind actually maybe put up?
Yeah.
So have you, we've worked on pull requests before, so have you seen sort of the inline comments and the way that
Yeah, I had a few things that I wanted to come in and push before I went for it.
Sure, okay, but, yeah, so exactly. So what's helpful here is that I've made an inline comment.
Yep.
And just said, you can do this kind of thing, see what you think. And so if you have comments or questions about that, doing it in place is really helpful. And then what's nice is if you actually do go in and change, then this comment will sort of disappear and it collapses it's just been taken care of.
And then, so I know that you've done this ref back equals properties, integer, and then I'm assuming that we're fine with that. It's kind of the name you're giving it.
So this is actually the doc string.
Is it being stored as a?
Yeah, this is a property.
Yeah, but is it? I guess it's being stored as a private variable underscore ref back.
No, so this would be, without the underscore, it's public. If you stick the underscore in front of that.
I know that.
But because, so the way that you've accessed it is through a lazy loading. And so I believe that below you actually do have a property called ref back that asks for the value of the private property.
Yeah, that's what I'm, that's
So
what
this-
I've done. I'm wondering if
Yeah,
that's
so
what
this
is doing.
this replaces all of that functionality. So just by saving this, you can actually remove all of those lines because this takes care of that.
Yeah, so somewhere in this properties business that you've done, you are storing it as a private variable underscore refract, and the property is called refract. You're still doing what I'm I'm doing here. You have a cleaner way of doing it. I just want to know, are two different things happening, or is it the same thing with different syntax?
It's on the surface, it's the same thing with different syntax. Although the implementation is like slightly different, so there actually isn't a private variable called refract, but like effective, it acts like there is. So it doesn't matter. Like under the hood, it doesn't matter. They're doing the same thing. They're just doing it in different ways.
Yeah, I just found them. If you store stuff using the exact same thing as what you define the property as, then I've run into some not so happy things.
So this will prevent you from doing any of those kind of crazy things.
Okay.
So as a user.
The other thing then is, as long as I can also sync this up with like a KWRs. That was one of the important aspects of why I went through all this trouble, is to set certain things. When I did an instance of that class, and I created an object, and then also have the ability to change or get the property after the fact.
Yeah, so
It's very important.
when you instantiate any of these properties, you can provide as a keyword argument. So anything that is defined as a property, you can instantiate as a keyword. So I'll send you an example with the stuff that I've done in the casing side of things.
It's a good review.
So,
Sweet.
So like I think in order to bring in a new contribution, it's going to take a few passes of reviews. And I'm sort of wondering how we want to structure that, because I think, like, especially for new contributors, it's really important that it's clear like what we're trying to achieve at each stage. Because if you get like 4 different reviews and each one is asking you to fix stuff and you don't know why, that would be really frustrating. Yeah. So thoughts?
Wiki?
Yeah, go. Oh, wiki, I don't know.
Or like, I guess almost even on like, what should we be looking for at each stage? Like, I think first getting structure right. Naming conventions, I think, is important. And then I guess drilling down into the details a little further.
After.
Yeah.
I think it's going to be so different every time, depending how complex it is.
Yeah.
Like he's bringing in a whole class, right? So that's obviously a lot of work. But.
Yeah.
Well, when doing this, I tried to follow what is the uniform, like, naming convention for the files. So for time domain problems, there was separate .py files for transmitters, receivers, problem, survey. Yeah. And then I went to look at a different problem that we solved, and it wasn't set up that way.
Yeah, and so like, I think what's
there wasn't a lot of uniformity in terms of that.
Yeah, and so that's where like a review I think is really helpful, is because we will get a few perspectives on it and try and decide like a bit as a community where we're trying to go. So it's not necessarily that like all of the code is currently in Swarm or left domain. It's not. But as much as we can try and like sort of point new contributions in the right direction, that's really going to help. And so that's really like a huge part of the purpose of a review, is to really help, get some feedback, get some input, and like get your code into other people's heads. So it's going to take some time to do that. Yeah, and that'll also hopefully help clarify some of these questions that you have, like why on earth have you guys structured this piece this way and this one this way? And it could, like, there are certainly things where it's like, well, that was our first implementation. We've learned a lot since then and haven't dealt with it yet. So like there's a lot of code like that sitting around.
So yeah, you're right. I guess the first is the structure, the core functions that we need. The JVEC, G2VEC, all that stuff.
Yeah.
Properties, you're right. I guess properties is like throughout, right? We need kind of I need to review my codes and everything, like.
Yeah.
And then we can go optimize the last pass. Then we could do an optimization, like figure out where we can clean things up.
Optimization, and I think testing is actually probably in the last stage of review. Because although it would be nice to have it early,
Unless the code is working fully and you're not gonna test it.
I tested mine,
What's that?
I tested mine against the MATLAB VRM code.
Yeah, but you will need to write unit tests, right, to hit.
Oh, where those? Yeah, I did
Code.
that, and that definitely needs to be done.
Yeah.
yeah, and exactly, it can be done in stages, so it doesn't have to be done right away. But just sort of, we want to make sure there's a bit of a clear trajectory, and also set the expectation that there are going to be multiple review passes of this. Is like we're not going to catch everything. So.
But so like having a project, what was that? That's actually helpful.
That's really
Otherwise, like, it's kind of hard to follow who's actually reviewing.
Yeah.
who's doing what.
You want to do it as issues, or we just do comments on the, because that's the thing, right? So right now, like you commented let's say you made a comment on this section here.
Yeah.
As soon as Devin changes this part here, your comment's gonna collapse, right?
Yeah.
But that might not touch everything that's inside here. We might lose that comment somehow, but
Oh, you can still always view them again. I guess like in part, that's sort of a bit of a social responsibility contract between
the developer and
and
the reviewers. Yeah.
If we need to, we can do them as issues.
No, that's fine. That's probably better like this, cleaner, right?
It's just helpful to have it in place.
Yeah, that's good. Yeah, that's a good idea. Shag, let's create a project for VRM as its own.
I mean, the ultimate goal that I have for adding VRM stuff is I want to predict VRM, predict a time domain EM code, add the time domain EM data to the VRM, and then invert some of the time channels, and then subtract off my predicted everywhere from that data set and see if my EM data from that problem matches that remainder. That's the ultimate goal of what we're going to always try to do.
That's your goal,
That's
but
my
VRM as a byte size should be self-contained, you know how to say it.
Yeah.
Forward and inversion. The rest is your research, right?
Yeah.
Your script that you're gonna build with like the time domain code and the VRM code, and then, but that's like way higher level.
Well, we got all the pieces.
Yeah.
So, all the pieces.
All right, that was a long meeting. That's great. Good job, Del. Good PR. Great project.
Yeah, this is exciting. It's really exciting.
Well, unfortunately, I have to work on 350 stuff. I can't keep involved.
That's all right now.
Yeah, are there any other things before? I'm gone this Thursday.
Next Thursday, you're leaving?
No.
This Thursday?
Yeah.
Oh my God. Okay, no, that's okay.
Okay.
We'll see
I
you
mean, I'll still
online.
be in touch and
Yeah,
I'll
yeah.
be online and stuff like that, but
Yeah.
I'm not present until.
Really? Wow.
Well, because we get back December 2nd, and this is silly. We fly to Calgary on the 4th, so we're here for like a day, and we get the disc in Calgary, and then we're actually. So you probably won't see me till December 7th or 8th.
That has to be on 8th, so.
Is that what's the 8th?
Comprehensive.
Comprehensive?
And so our